Okay, perfect. Yeah, I don't have any specific slides for today. I have a short document with some of the areas which we discussed last time, but also I heard that you started some new area. I can start doing some notes and then share that after that in Slack. Let me share my screen.
Yeah.
Let me know when you see.
Yeah, we see it.
Right. Yeah, thank you for having time today. Also for this work group meeting. I wrote down some of the 4 points what we identified as some which might need some discussion regarding a plugin framework inside Kubernetes for resource management. Like one of the the points which we rolled was plugins fail safety. What happens if the plugin fails? And this plugin, let's say, is responsible for management of the resources. So one possible thought what I had, like if we have some small kind of piece of core code which does more or less the basic stuff needed to host the pod, basically just similar to best efforts class, best efforts quality of service, what you can get without any CPU manager and so on enabled. So what we can do, if a plugin fails, we can fail back to this best effort core component. It can be included in some sort of central manager. Right, I don't know if this sounds reasonable, but it's one option what we could have in terms of in failing cases.
Atanas, I have one question. So when say a resource plugin registers itself, how does it, how are those resources observed on the node itself? Like, is it an extended resource that we see that has been added to a node, or is it some other object-based mechanism?
The CPU resources, how, or you mean like CPU memory resources, how are those detected?
Yeah. So what I'm trying to understand is, like, if I were to write a plugin, what at what with what API semantics I'm going to expose the resource? Like, will it be so device plugin exposes an extended resource, and that's what we request in the pod spec. Are we do we intend to move in the same direction, or do we plan to do something else?
For exposing the resources, one option we were thinking is if it's possible really to use dynamic resource allocation also for such kind of, or generalize it to be able to handle more cases, not only devices. So dynamic resource allocation could be one option to be investigated. In terms of detecting the resources, you can detect the resources if you have privileged access to the kind of the underlying system detecting the resources. It's not impossible. Right.
How do you think that DRA would kind of scale into bigger clusters for like handling these kind of resources? Because
I think you will have several cases. You will have DRA basically for we know that DRA has, what I heard, that it has some issues at least in terms of but also in scalability, most probably I don't know exactly for how well it scales DRA and so on. But we are thinking there are three three things which has to be covered. There is it would be great if we can use the dynamic resource allocation API also for our purposes. Then, of course, you have users who want to use standard CPU requests and limits. So you want to enable those too. And the third cases, of course, are standard mechanisms to use devices, like the standard device plugin mechanisms. So I think we have those three paths more or less to cover.
But Atanas, if you have user specifying CPU as both native resources and DRA, it's exactly will lead to problems in double accounting. That's exactly the reason why. Well, that's exactly the reason why DRA was not covering native resources.
Those should be not existing together. So if you use DRA for CPU control, memory control, you should not specify the other way around, like CPU resources. I don't know if it's doable in terms of implementation, but yeah, it would be nice not to specify twice.
Then the portability of applications with it.
Well, yeah, sorry, I have a general question. So, like, is this solution going to be kind of generic replacement for all plugins mechanism? I mean, like, is it only about like device plugins and like CPU or native resources, or it's like it's supposed to cover everything?
That's the ideal situation which we would like to achieve. Basically, if we have a general plugin solution which can cover all three cases, basically.
Well, it's not three; it's four cases. There are like the at least CSI plugins that I know about, and those. Have you looked at it? Have you considered them, or they are kind of out of the picture?
For now, CSI plugins, I did not look at those.
I'm not sure I understood the answer to the question. Is the desire for all resource management activity not to be in tree in Kubernetes?
Is it possible?
Can you answer that? Is that the desire? I guess that's what I want to know.
Mm.
That a user of Kubernetes should have no, without going to a third-party ecosystem or community, should have no resource management?
If you think about normal OS, just think about your OS, Linux, or whatever. You download drivers from vendors, right?
I just want to know, is that the outcome? That Kubernetes should not have any more, or should aspire to offload any built-in resource management?
Should have unified driver interface, something like that. This is what we are after, more or less. Similar to, yeah. So basically, if we have very good abstraction of a driver interface.
Okay, and then extending to that, the container runtime that Kubernetes interacts with, should it or should it not aspire to be the resource manager for the containers it launches?
This is why, in terms of resource management, if you rely completely, or there are several options. You can rely on runtime to do resource management, but if you have the capability to write a custom driver, which can do more, and certain users will need more. So
I guess it's not a very, like, I'm having trouble rationalizing that with a guiding principle answer. Like, and I get a sense that the answer is to yes to all things, which is then making it hard for me to rationalize what things should ever go into Kubernetes again. Like, is it good that Kubernetes manage PIDs? Should Kubernetes aspire to be more granular on how it manages PIDs. Should Kubernetes manage block IO? Should it not? I can't tell in this conversation if it's a mistake that Kubernetes manages CPU and memory, and it should stop doing that and work towards a world where drivers do it. And related to that, like, is it a mistake if container runtimes advertise CPU, memory, block IO, and should they also plan for delegating to these drivers? I'm just trying to figure out what the non-fragmented end state is.
Derek, I can answer for at least like some bits of.
I've been trying to talk for a moment, Sasha, please. So as we go forward, the CPU and memory, with Kubernetes, the whole point is for pluggable infrastructure. So when you have particular components managed internally to Kubernetes, we start getting the issues that we've had where there's a bunch of different managers being pushed into the kubelet, which the community has to update, right, and maintain. And then more features, now you have to do that there. With CNI, with CSI, having that pluggable infrastructure is really nice. And that's where we're trying to go, is basically turn Kubernetes into a pluggable infrastructure or kernel, I guess, going forward. Go ahead, Sasha.
Derek, I just wanted to answer a couple of your questions, what you asked, like regarding like the announcement of resources from runtime to the kubelet. In my opinion, it's a long-term what we should be heading to. Reasons for that is what right now we have a situation where like some of the resources are configured on both sides. So for example, like C groups driver, like reserved resources amount and so on. And we observed what many of those things are misconfigured, or like users have different configuration on both layers. So right now, like all these activities, like this container plague events or like stats for containers is already moved to runtime. So it might make sense to be a bit more of this resource discovery moved to runtime as well. So at least it will reduce some of the misconfigurations and simplify some of the code inside Kubernetes. Regarding like other things like PID and so on, the question is, well, the answer is, at least from my side, my personal opinion, I don't know, but having in mind what we have right now, like different runtime classes, like we have Kata, we have Firecracker, and so on. So assumptions what we previously had with Docker Shim about what like we have always C group, we always have like PID in the host namespace and so on. This is not true anymore. So technologically, it's probably better to split the responsibilities between what and how between the kubelet and runtime. Where this borderline is drawn, it's a separate question.
One question regarding the runtimes, don't you think that they become too Kubernetes specific over time?
It depends. It depends. So now you are the cryo maintainer. You know you can say a word about that here. But
yeah, so I think good. Go ahead, Sasha. Finish your thought. I have some.
Yeah, my thought is really simple. Is what like if we look at what Containerd is doing. So the cryo plugin inside of it nowadays is rewritten in a sense what concept of a sandbox, or well, something similar to concept of a pod is already a native internal data structure inside Containerd. So it's not really Kubernetes specific, it's more abstractions what is already industry standard of how we are running containers. So we know what we need to have a common like sandbox which groups containers. We know what it should contain like network. We know what it should consume resources and so on. So it's not really Kubernetes. It's more about like all different infrastructures which runs the unit of workload. But no, please. you're a better expert in that area.
Yeah, so I think like the challenge with pushing everything down to the runtime is like Sasha, like every runtime will have to keep implementing it. The second thing I worry about is right now we have a dependency just on CNI, right? Like if we start depending on say 5, 6 different plugins, how are those plugins running? How are they bootstraps? They can't be containers easily because the runtime is depending on them. Are they native services? How are they delivered? So that gives me pause to aggressively push everything down to the runtime, like through and depend on more plugins
I-
there.
I'm not saying everything to runtime, and I was just answering to Derek's question about the resource discovery. But in overall about the plugins, so like if we look at the majority of Kubernetes installations, it's usually like VMs in some cloud infrastructure. So underlying cloud provider infra is doing the majority of the work. So the plugins might be really needed only in the situation where we have either bare metal or special installations. So like depending, like no, your comparison to CNI might be not fully, how to say, fair.
Just to
In
add,
terms of plugins.
the objective of the plugins can be also to enable more complex optimizations to users in another way. So um, I think this is not completely true for that it's only in the specific case. It's only in the specific case because it's very complex to configure them today.
Yeah, if it's okay. I guess where I was going, my question is, in our prior meeting on Tuesday, the slide you showed a world where the manager of the resources, like the thing that communicated from to the container, that was the container runtime. At least for some resources you said, and maybe not for some others. And I was trying to figure out how to evaluate that. And then related to that, the vehicle by which the container runtime was communicated with was still always the kubelet in the flow you showed on Tuesday.
Let me
And then just to let me finish my thought, if that's okay. For some resources and not other resources, that might make sense. But in some conversations, it seems like there's a desire to maybe go one step further. And that's what I was just trying to see if there's a real desire for, and if it could be vocalized, which is like the kubelet should not manage any element of the C group hierarchy. It should not manage the quas hierarchy. It should not manage the pod C group hierarchy, and it should not manage the container hierarchy. And it could be that there's some resources that would be explored that you think would be best served by having to meet a need at every level of that hierarchy. And I was just trying to figure out, like, is that really the end game that you want to get to, which is that as a design principle, kubelet and Kubernetes generally does not try to manage or model any of the C group managed or non-C group managed resources that might constrain your application? Or is it just the exotic and advanced ones that we want to delegate out to drivers? Like, I'm just trying to look for like the lens by which we would make future decisions.
Can I make a suggestion, Derek?
Yeah.
Yeah, so when we spoke last time, we also spoke in terms of bootstrapping. What happens when it first starts up? And then what happens if there's a crash loop for one of the components? So wherever your components are, they could still end up in a crash loop. So we need to be able to recover it to some degree. Or maybe we don't, I don't know. But going forward, the way I would look at Kubernetes is for the vast majority of the use cases, like the VM, not vast majority, because a lot of the customers we deal with, which is a significant component, including China, by the way, they are doing on-prem. So the on-prem environments are very different from the VM environments. The VM environments, I would hope that Kubernetes as is would be good enough, right? So then you don't need exotic plugins necessarily. Maybe you do for performance scheduling. I don't know. But for on-prem, you do need those plugins. Does that make sense?
Yeah, it's not quite answering the meta question I'm looking to answer, which is, do people dislike that the kubelet manages any C group on the host? And is the desire, when you talk about resource manager plugins, really to own every level of that hierarchy? And maybe there's an inbuilt plugin that does the quaz hierarchy and the pod level hierarchy. But really what you want in the end game is to be able to manage every layer in that tree where possible. And if that's the case, then I'll just kind of look at like features we have in flight today, whether that's things like starting to expose more C groups v2 native concepts like memory quaz. You know, would that even be a Kubernetes native thing? Like, would it be up to Kubernetes to define what a memory.request is anymore? Or is it something that your third-party driver has to define what that means? I can't tell what resource is safe for Kubernetes to add going forward in a world where this exists. I'm not saying this is a bad world where this exists. I'm just trying to figure out what things should be inbuilt in the community, I guess.
Sasha, you're raising your hand.
Yeah, I just didn't want to interrupt. So, Derek, answering to your question, it's hard. It really depends on whom you ask.
Well, that's why I'm asking this audience, right?
Yes, but even within this audience, I think like we have like how many, like 10 people, and maybe we will get 10 answers. I can talk about my opinion. Like answering to your questions, like the C groups hierarchy and so on. I think it's not the place to be done inside Kubelet. I understand all the historical reasons. I've seen it in the Docker shim times, because we needed that. Like Docker required the fat client to some extent, but we got different runtime classes. We got C groups version 1 and 2. So like C groups version 1 and 2, we needed to support them both. We needed to change both kubelet and runtimes and protocol between them to just implement that feature. So my personal thinking is like, why we are teaching with kubelet, why we are adding so much of technical depth inside kubelet for implementation details which can be hidden from that. So kubelet can still own the life cycle of a pod. So it knows what needs to be run with which priorities, but how it's implemented, like is it C group based, is it Windows container, is it some, I don't know, like WASM runtime or whatever, which uses different sandboxing mechanism. It's not really necessary to know to the kubelet. And I understand historical reasons, but I don't see like in like 5 years ahead if it's really needed inside Kubernetes.
Yeah, I have similar kind of feeling, more or less, basically with just touching some of the code of Kubelet. You see it, if you want to develop some sort of plugin or something, what you need is only exactly somebody to create the container C group for you and to destroy it when needed. The actual kind of things below that, right, you can manage outside.
Yeah, so maybe there's just a lot of intersecting things that happen with this. So just to maybe tease these out, like my naive view is that it's good that the kubelet and the Kubernetes community can, out of the box, without resorting to too many plugins, reasonably support end user applications for like what I would call a 99% use case, which would be things like I expect to be having CPU basic fair share quota and limiting in place, because it's kind of universal across every Linux host. I would expect memory and memory quaz to be available to me because it's basically universal across every Linux host. I would expect the kubelet to aspire to do better around PID management than it does today. And I would expect the kubelet to offer some type of priority banding around access to block IO as block IO improved relative to the kube use cases. Like those to me represent like the essential food groups that like 99% of users would benefit from. The exotic use cases, the specialization use cases, things like I need pinning or NUMA alignment or device alignment. I agree they are very often vertical and workload specific. And part of this discussion around the resource managers was how to accelerate those use cases. But where I'm struggling to figure out is if you want to accelerate just those use cases versus I want to take over total ownership of all resource management in Kubernetes. And if a new resource is brought forward that says, hey, does the Kubernetes community have an opinion on block IO? Shorter answer be no, it doesn't. Go find a third party thing to do it, or yes, it does because it might be in that 90% window. Tuesday's conversation was making me think much of the discussion was on how to support the specialized use cases without needing to get those specializations in the upstream versus the generalized use cases that the broader community can benefit from. I'm just trying to make sure I'm calibrating my worldview correct.
Don't you think that this generalized 99% base cannot be fit in very small code base? Like just if we, let's say, extract away all this kind of I don't know if this kind of generalized 99% includes also topology and devices stuff.
I think alignment and exclusive allocation of a resource is where I've identified, I think, specialized scenarios. But I think the things that we already had done in Cube, whether that was general CPU fair sharing, general, you ask for amount of memory, we're going to aspire to make sure you can get that memory. And the work we're doing right now with V2 to try to get you actually have memory requests mean something. All those are good. And I think related to these resources, there's some reasonable expectation that the kubelet tries to responsibly respond to scarcity of those resources. So I think it's okay that the kubelet tries to handle scarce memory pressure and resource eviction, or that it's okay that the kubelet tries to handle local disk exhaustion. I view those things as in that broad ship of function, I guess. But I'm really just asking, like, I'm not necessarily adverse to restructuring how the code is done to support that, especially if it's in a way that allows people to do pluggability. That's awesome. Mostly, I'm just trying to think about what things you think the community should say no to going forward. Mm-hmm. And I don't have a good sense. And that's what I'm trying to calibrate.
What about if we try to identify a minimal piece, what is needed to cover 99 or whatever percentage of the basic usage, and we cover it in this resource manager without pluggable concepts?
Right, that's kind of what I was asking, right? Like, did people reasonably think when I said what I said around CPU and memory and block IO and PIDs and ephemeral disk, like that's basically what we had in flight now. Is that not a fair starting point? And is there something else that's not there that we're missing? And would we think that thing should be fulfilled as a first-class thing through this path or not? That's what I was trying to figure out. That I totally appreciate that a lot of this in Tuesday's meeting was like, I want to do power management and I want to do maybe more exotic affinity and pinning scenarios. What I'm trying to figure out is where the line is in between. So.
But Derek, regarding the block IO, as I mentioned, it means different thing based on different runtime classes. So whatever we are assuming on the host, it's not the same what we see inside Firecracker or Katavia. So if we implement it in Kubernetes in any way, we need to make it abstract enough to actually hide the internal complexity of implementation of runtime from Kubelet. And regarding what you mentioned about the memory QoS, I don't see the reason why we need to say no to it or stop it. Like, why not? We can implement it, but when later on it will like shape it into a like big future.
Yeah, I guess this is where I come back to like you made a comment there were like 10 people on a call and there might be 10 different opinions. I'm just trying to figure out how to figure out how big of a bite we want to take on this step and or this particular activity or not. I'm not trying to make a value judgment on yay or nay either way, but I'm having a difficulty like getting a forward-looking perspective, I guess, for how to approach maybe more general resources. And the things I enumerated were just things that every container runtime supports today. And so I was trying to think if the community's posture was it's generally available in every container runtime, then it's fair game within the Kube community to try to support out of the box. That was one very simplifying perspective I was just trying to articulate.
Yeah, I think I kind of share some of the sentiment there, Derek. So like, I don't think we should try to fix what's not broken. We have resource management kind of working well in Kubernetes, but at the same time, we want to enable some of these exotic use cases, like you said. I was wondering if there's a way that we have a separate pool of resources that we just hand over to these resource plugins, so they can manage them.
Just to interrupt, sorry, Sati. I think the status of the current management components is not satisfactory. It needs refactoring.
Yeah, so I completely understand that. I'm okay. What I'm suggesting is we can refactor it and make it pluggable in a way that it adheres to the plugin-based APIs. But out of the box, we give people what exists right now. So for example, if they want very basic CPU pinning, you have your request equal to limit and you get exclusive CPUs. So things like that, we can give them that as is. And if we want them as in-tree plugins, we can do that. We just refactor the code, have maybe CPU manager static policy as an in-tree plugin available internally, but we get that out of the box.
This is feasible with this approach. So you can have an in-tree plugin basically for this exactly basic stuff. And some of them you can maybe pull out as we wrote in small core components. Like in some cases you even don't need pinning and stuff like that. So this will be 90% of the cases, like best effort containers, burstable, and some memory limits. I completely agree with Derek that a small core would do that.
So I think the missing piece so far is that we haven't discussed how do we make sure that these in-tree plugins and say the new plugins that we create don't take ownership of existing CPUs, like the underlying CPUs, and they don't conflict. And like Sasha said, track them multiple times, and there's accounting errors. So in
Exactly.
order to take care of that, maybe in Kubelet we can create a flag where we separate the pool of resources that is given for resource plugins in general.
My request when we go forward isn't to look at what we have today necessarily, because we're basically coming up with a design of resource splitting in the future. So I'm going to go back to topology management doesn't handle most of the use cases that we're looking for, even in specialty cases. So I would ask that whatever default plugin that we have going forward or default behavior, we keep as lightweight and simple as possible and not continue having to support fancy features. And that includes pinning.
Yeah. So what the distinction I'm trying to draw, Marlo, is there's a difference between supporting CPU and memory out of the box, let's say, and versus someone that's trying to get where each of those resources are kind of implemented in isolation versus the use case that is requiring them to be co-scheduled, like in a way that is not representative of the default way, like say your init system would launch any other service on your host. So like topology manager to me is like a clear advanced use case versus the is it right and proper that Kubelet is aware of, you know, memory pressure, right? So the only thing I was trying to draw out here is as we offload resources to these specialized managers, we have to keep in mind that that manager is responsible not just for assignment, but also for handling scarcity and pressure, which means every resource manager then needs to become an evictor or a potential evictor. And I that's what I'm trying to figure out is what function as it's delegated out also needs to go with that delegation. Yeah, I'll basically pause there.
What I'm trying to figure out is how the picture would look like from the API point of view. So currently we have like pluggable device manager, pluggable DRA manager, unpluggable topology manager, unpluggable CPU manager, and unpluggable memory manager. And the idea is to somehow like combine it in one resource manager, as far as I understood, but and make it pluggable. So, and I kind of cannot figure what kind of APIs would be. So would it be some kind of like proxy manager that would proxy the request from Kubelet to the plugins? But they are going to have like different APIs, so that is not very clear to me. So if anybody can explain this.
Let me move back to this picture. So the resource manager is a component on the Kubelet side which manages the plugins. So
what kind of plugins?
You can have the three types of plugins. You can have a common for the basic stuff, basically. The things what you have today: CPU manager, memory manager, and topology manager, like packaged together in one plugin. Then you can have device plugins. You can have DRA plugins. They just don't connect through 10,000 managers. They just go through one. Right, and then the new things here are you have the capability to replace this one. If you are a vendor or a company which wants to implement something custom, you can basically implement this one. Also, devices and everything else should work as before. So we don't want to basically be incompatible with device plugins or DRA plugins. So, but yeah, that's the coordinator is actually this resource manager, it's the central coordinator.
When you said this one, you meant resource manager. So I thought that resource manager would be like still part of the kubelet, and it will just communicate with like different kind of plugins.
Yeah, exactly. It's only communicating with plugins and coordinating this plugin kind of communication. Actual allocations and stuff like that, or state handling, state machines are done here in the plugins, so they are externalized.
Yeah, so that for me it means that it's just like gathering the code of the for example, device specific code from device plugin and CPU specific code from CPU plugin and just put it into the like one manager. But I don't see like any reduction of the code here. Well, maybe it's a good thing to get it together, but
no, the
like,
kubelet codes will get reduced. So
how?
Or basically here, all those three things, they are part of kubelet code today. If we host that as a plugin repository, similar to SIG scheduling, basically, you can have this as a separate repository, basically external from kubelet. Then you have further options to reduce the code later. Maybe some of those pieces, device manager and DRA, they can be simplified and merged inside.
Sorry for interrupting. So like let's not talk about plugins so far. Let's talk about the manager. So what we are going to do is to get all these 4 or how many we have, like 5 managers code, and put it into one manager. So how that would reduce the kubelet code base?
It won't be in the kubelet code base. It will be in some plugin.
It has to be, because it has, like, for example, device manager has device managing specific code that cannot go away.
Device manager remains inside kubelet. This we don't move so far.
Yeah, DRA is the same, so it's different thing from device manager and from CPU manager.
Those two we keep inside. They become children managers, resource manager of the central resource manager.
Okay. So like the idea is to, like, mostly the reduction of the code will come from the CPU, memory, and topology manager, right? Because part of that code will be like plugged out, so to say. Yeah. Okay. Yeah, understood. Because I thought that it's all the manager will be like somehow like generalized, and the code will be like
ideally
less code.
this should be the objective, but it's not doable in short term, I think. So I think what we need as intermediate steps is definitely device manager and DRA manager as children, basically, of this resource manager.
Yeah, well, I'm just thinking like how like this is different from just making CPU, memory, and topology manager pluggable.
Like a third one, it's you could do 3 managers, right? It's still better than having 5 today.
Okay.
It's still a win. Going to 3, it's better than 5. Ideally, we want to be at 1, but if it's possible, it's another question.
Okay, we need to think about it. So maybe I just misunderstood the proposal. So I thought that it's kind of like general proposal for all kind of managers, all kind of like managers inside Kubelet, and just. But so okay, so device manager will stay the same, DRA will stay the same. It's mostly about CPU, memory, and topology managers. Yeah,
right.
Understood.
Yeah, and this is a little bit just to explain back to this kind of core functionality. What we can do, we can have a small core component which covers 90% of the use cases. This would be really nice if we can extract from those three. What's the basically the most important thing for users, and somehow put it basically in three. Or if they want all the things, they can take this default plugin is one option, but we can host maybe a small piece which is basically needed for 90% of the use cases in three. Yeah, so right, so this was a little bit on the bootstrapping part. We were thinking that in any case, such kind of small component, core component might be needed in for fail safety reasons when the plugin goes down or something, or if you want to cover functionality without plugins much faster, which is very basic functionality. Right. And yeah, the other very quite open area is how we can, if it's possible, to extend the array to handle basically CPU and memory, because the interface is nice. We would like to use it also in that space. Our users would like it also in that space. We are thinking why not try to generalize it?
Well, currently it has only two calls, like prepare resources and unprepare resources, and that's I'm not sure it will cover like this all this CPU and memory specifics.
We don't want to cover all the CPU use cases. We would like to stick to the DRA interface as it is today, but just basically provide. I think it might be that the two calls are sufficient also for that, but it's to be checked. So basically, we don't want to cover the standard interface of resource requests and stuff like that through DRA. We just want to have the same interface for basically CPU and memory for more advanced use cases when you have maybe more advanced kind of definitions how the CPU has to be allocated, how memory has to be allocated, then DRA can pass more details basically through that interface.
Well, I don't know, at least for now, CPU and memory, the allocation happens on the like admission kind of stage, but on DRA allocations happens before actually the workload scheduled to the node. So not sure it's so that's kind of, for me at least, it looks like a different things, very different.
Yeah, so you have basically some sort of pool of resources which is allocated, and then you're claiming for when the container comes.
Yeah. So that's the whole idea. That like the resource claim is actually handled before it's handled by the DRA controller before the workload is actually scheduled to the node. So the scheduled decisions made and allocation actually is done before that. And scheduled decision depends on the controller part of the DRA plugin.
Right.
So not sure that it's a good place to actually allocate CPU and memory. So for devices and maybe for storage, it would work, but CPU and memory are like local resources.
And your you're scared about scalability mostly, or why are you worried about if the user actually wanted those resources, exactly those resources, why not allocate them? What's the issue with that?
I don't know. I just cannot wrap my mind around this idea. So for me, it's like it's local, but the array is actually meant. Well, it can also handle like local resources, but mostly it meant like to like general, more like generic approach that would also kind of can make the remote like devices, like network attached devices and stuff like that. Those are not local to the node. So that's why actually this idea came, because it's not about local resources. So the some resources they are like not attached to the node at the moment of allocation. So that's one of the ideas like behind the array.
But when the bot gets scheduled and gets started, it gets those resources, or?
Yes.
And this is exactly what users.
It already, the resources are already allocated. So they are just like on the kubelet level, on the DRA kubelet plugin level, they are just like prepared, and preparation is just a matter of writing the actually the change to the configuration, runtime configuration, runtime config. So that's what the DRA plugin do, at least for now, currently.
So I admit I'm now also a little lost, and so I'm trying to think of ways to maybe get some clarity. Is it possible? So a clear piece of input in this call has been that a perception that there's too many managers inside the kubelet today for CPU memory devices and then their intersection with topology. And it seems like the use case through which all of those managers reach some tipping point in this audience is when they need node local scheduling awareness. And the fact that there's 5 of these instead of 1 means that, you know, in the case where they all need to intersect as well, it seems like their desire of, I just wanted 1 and it could work for my use case across CPU memory and topology and, you know, what else might be in our minds here. So maybe could we just do like an exercise of saying in a world where there was just a new CPU manager added following this model, what would be the bootstrapping flow? And what is the use case that this new CPU manager is needing to satisfy? That would all give us confidence. For like the first question here, it says, if it's down, we fall back to the built-in version. What would give us confidence to even know that's the right outcome or the right safe solution? That's what I'm trying to figure out, how we answer questions here. Do other folks have ideas on how this could be explored or thought through?
Maybe by showing it, it's not a bad idea. We can try to prepare some sort of short kind of CPU manager plugin. We have a prototype in place. So we can basically try to implement a plugin which doesn't fall in the standard, let's say, functionality what CPU manager covers today.
And in your prototype,
Mhm.
you must have an opinion if fail open or fail closed is desired, right? Like, it's not like people would write a new CPU manager because
Yeah.
they didn't need the function, right? Like, is there a view that you would have on that for the one that you wrote? Like, is it actually okay for it to fall back to the built-in one? And if so, why?
For the fallback, I did not implement that functionality. So for fallback, but it's something which we can basically try to build in and simulate some sort of more
But
corner case.
Given what you were exploring, though, do you have a bias on if you would think it's okay to fall back, or does it break the desired state?
It will, yeah. So you mean if it is it in the case when the pod is already running, which was scheduled, and then manager breaks, or is it during scheduling? At what point are we speaking about the break happens?
New pod admission,
Mhm.
pod restart. Like I think of, I guess, those use cases. Right now, I struggle to think of why fail open would be desirable. And I'm probably biased by a worldview that because everything is composed as it is today, fail open isn't actually possible. And that has biased users to know that that things are just going to kind of work as they think it's going to work, or hopefully it does. But I could see how if you had a fail open posture for these plugins, that would cause a lot of confusion, particularly for those users who are expecting the most optimal placement, right? So anyway,
Right. How do you inform the user that the placement was not as desired if you maybe, right?
but I
Yeah.
feel like if you get to a spot that says, I don't accept fail open, then
Yeah.
you might get to the next step that says maybe Kubelet self-managing these plugins via pods is not a desired design constraint. I feel like having Kubelet manage these things as pods implies I'm okay with a fail open or post bootstrapping position. But I'm trying to understand if that's really where people would be okay or not, versus, to Mernal's point, just the bootstrapping problem. Is deployment of these things as pods the right approach? But to me, if you desire fail close, then you shouldn't depend on a pod in order to create pods.
Right.
Derek,
Maybe can be.
Can you a little bit elaborate? What do we mean by fail open, fail close?
But today, for example, I'm sure we all are doing our best to represent users in the community who are running workloads on Kubernetes nodes that desire, pinning, right? And fail open would mean, okay, the CPU manager wasn't available, so I couldn't make a pinning decision, so I'm just going to not pin your workload. It's going to go on all the CPUs, or it's going to get some default decision. I'm not aware of a user that would be happy about that in the case where they actually defined or desired pinning. It would be actually very disruptive to the other workload on that node. And so I feel like that class of user desires a fail close scenario, right? No pods should be launched, or no pods should be scheduled when that manager is not available. And then if that's true, then using Kubernetes to bootstrap these managers as pods themselves may not may not work out. I'm really struggling on the bootstrapping loop here.
Okay.
What about if you give the control to user? Like if the user tells, let's say, I'm okay with fail open.
So,
And then
Derek, if I may throw an idea to the table. So right now we have like topology manager and the rest of managers is configured as a like the whole node thing. So we assume that if a node is available in this particular configuration, then we can assume what the algorithm is working. However, we don't have a fine-grained control on the pod or on particular container, what actually important for the workload, like memory pinning, CPU pinning, both, or devices, or any combination of it. So one of the reasons why we want to introduce QoS class resources is actually to give a field to a container to actually specify what is important to it. We, of course, had it in mind with a bit different scenario. So like when you have a host with multiple tiers of memory, with different type of memory available. But it can be used for something what you mentioned was scenario, when the user can say what this container is critical to be like on an isolated CPU set, or like to have perfectly aligned memory and CPU cores or devices or whatever. So the QoS will allow us to express that thing between also user in the pod spec and the like underlying bits which actually do the picking.
how does this connect with the fail open, and I did not get it.
Very simple example. So like if container is said, I want to have a ping, and until the bootstrap is finished on the node, the class of I support the CPU pinging will not be available. So scheduler will simply not put the pod on this node.
But can you specify the other behavior? If the user is okay that this goes on the node?
Might be. As I said, I'm throwing the idea to the table. But I think we can. So if we expose,
I'll just go out here on a limb and say, like, so the way I look at this is that I don't need a CNI in order to launch all pods, because all pods don't require a CNI, and this is why many CNIs can be delivered as a daemon set. But if I need a pod to launch pods that use CPU correctly on that node, that will cause conflicts. I represent users where that would be a conflict. And so I wonder if I'm alone in that user representation. And if I am, or maybe I'm mistaken, I'm wondering why others would have more confidence than I would have on saying that in order, since all pods need CPUs, and since all nodes that tend to have CPU topology or NUMA assignment tend to be very specialized, can someone help me be more comfortable with needing a pod to launch pods? Why might my mind be miscalibrated on that?
Derek, you are not alone. Definitely. Sorry, Christian, 1 second. So the difference is what, like, different users, or even on the single node, might have different preferences. So like if we look at the example of, let's say, like network card plus DK workload, you need to have everything aligned very perfectly. But if you have FPGA, you don't really care about the CPU alignment, because the whole thing is happening on our board. The same applies to many of the applications. Like some don't care, some they actually care about partitioning of the system. So
maybe the most proactive thing I can say here is that, like, my current view is that if we pursue this, me as a user or a provider of Kubernetes solutions, I personally would bias towards plugins that are not managed as pods themselves to avoid this chicken and egg scenario. And so maybe just as a design tenet, we should call out that it's not a requirement to manage these things, or we should make no assumption that these things are managed as pods themselves. And if that was okay, then we could avoid having to deal with maybe some of the failure cases. But if I have to assume that these things can be managed as pods, then that means I have to deal with a larger set of failure cases than if I can assume that they don't need to be.
Hold on. Can I speak? Is that all right? We're past the hour. Derek, you're onto something here, I think, as far as managing outside of pods, because as long as you have an interface, and you can just speak directly over the interface, you don't have to have that assumption. With the time in mind, do we want to do another meetup next week, or should we wait for the new year? Because I know other people have stuff to do.
I encourage everyone to meet and discuss. Don't feel you need to block on me. I will not be here anymore after this week for the remainder of the year. But I think good discussion obviously happens among a group, even when I'm not here.
Sure, but
yeah.
a lot of people I think are on holidays because of
Yeah, it would be lovely to have a Kevin on this chat, but he is also away for holidays.
Okay, we can start again after the new year. So I'll send out another Kalindi poll thing, and then I'll set this up again.
Then
The doc is in the link. If anyone wants to update with notes, please go ahead. I didn't do a great job because you're kind of going back and forth on the same topics.
Marlon, may I ask for some practicalities? So if we're resuming these meetings after New Year, can you actually send it properly as an invitation to sig-node mailing list?
I can
Because
send it to sig-node as well, because it was suggested that I send wrote in the Slack, so that's where I did. But if we want the mailing list as well, I can. It's
easy to mailing list because not all people can monitor all the threads in the Slack, or not everyone joins the weekly meeting. So I know a few people who missed the notifications.
Yeah, so let's just get the meetings on the sig-node calendar, and anybody who subscribes to that calendar will see the meeting.
That's a great idea. Who do I contact on that, Derek?
I think myself definitely can do it. Sergey, I think you can do it. So it should be fine. I think. Am I mistaken on that, Sergey? You have that power as well, unless he dropped.
No, I'm still here. I'm not sure. Is there a special calendar for that? I thought there's just a main calendar.
There's a sig-node calendar, and I'll look up. I know I can add things to the sig-node calendar. I thought other sub-project owners could add things to the calendar. Let me quickly try to look that up, and I'll ping you, Marlo, and we'll figure out how to make that happen.
If I can help, just let me know. But I don't think I have permissions.
Okay, thank you. Atanas will get you the recording, Sergey, so we can put this also in the mailings.
Thank you. Wish you all happy holidays. Thank you.
Happy holidays.
Cool. Bye, everyone.
Bye.
Thank you. Bye.
Bye.